Alright, here is today's bell assignment. Please pause the video so that they can work on this at their own desk. When you're finished, please put one at the board and discuss it before you play the rest of the video. What we're talking about today is lesson 74, simplifying square roots. We've used the Pythagorean theorem. If I move this, yeah, it's going to mess everything up. Okay. We've used the Pythagorean theorem to find the diagonal of a 1 by 1 square is radical 2. Since the area of c squared is 2, the length of the diagonal is radical 2. The diagonal of a 2 by 2 square is radical 8. But notice that it is also 2 times radical 2. We simplify radical 8. Oh, whoops. Okay, I'm sorry. I thought I skipped out on something over there. We simplify radical 8 and 2 radical 2. Okay? So what they're saying there is that radical 8 is equal to 2 radical 2. And here in a minute I'm going to show you how that works. Okay? The diagonal of a 3 by 3 square is radical 18. But we see that it is also 3 times radical 2. We simplify radical 18 to 3 radical 2. In this lesson we will learn how to simplify some square roots. We simplify square roots by using the product property of square roots, which states that square roots can be multiplied and factored. We symbolize the product property of square roots this way. So the product property of square roots is that radical AB, which is A times B inside of the radical, is equal to radical A times radical B. And that's how we simplify this, because what they're saying is radical 8 is the same as radical 4 times radical 2. Well, we know that radical 4 is equal to 2, so then we just tack on that radical 2. That's where they're getting that from. To help us find perfect square factors of square roots, we can write the number under the radical sign as a product of primes. Then we look for pairs of identical factors. Each pair is a perfect square. Below we simplify radical 600. First, we write the prime factorization of 600. So that's the first thing that we have to do. We need to take the prime factorization of 600. 600 will split into 60 and 10. 60 will split into 6 and 10. 6 splits into 2 and 3. Those are both primes. 10 splits into 2 and 5. Those are both primes. 10 splits into 2 and 5. Those are both primes. So this is equal to radical. And under that radical, we can list this out as 2 times 2 times 2 times 3 times 5 times 5. And they said that we look for pairs of identical factors because each pair is a perfect square. So once we have it like this, we can just take any of those doubles and we pull them to the outside because that's a perfect square. Radical 5 times radical 5 is just going to give us 5. So on the outside we'll have 2 times 5, and we're left on the inside with 2 times 3. Okay, you can only pull out doubles though. So 2 times 5 is 10. Radical 2 times 3 is 6. Final answer. Square roots can be simplified by removing perfect square factors from the radicand. If the perfect square factor is apparent, we can factor in one step. So they said that they saw that 600 split into 100 times 6. What I have found is generally middle school students do not see that very quickly. So I just show you to do it this way because this is foolproof. You won't mess up if you do the prime factorization correctly, and you don't have to worry about finding that perfect square to multiply by, okay? If the perfect square factors are not apparent, we write the prime factorization and look for pairs of common factors. So, on A, we need to write this with the prime factorization. So we're going to split this up. We're going to say that this splits into 3 and 72. 3 is a prime. 72 splits into 8 and 9. 8 splits into 2 and 4. 2 is a prime. 4 splits into 2 and 2. Those are both prime. 9 splits into 3 and 3. Okay? So, I have radical. And instead of 216, I'm going to write the prime factorization, which is 2 times 2 times 2 times 3 times 3 times 3. Now I can pull out any of those doubles. I have one pair of double 2's and one pair of double 3's. So I pull out 2 times 3, and I'm left with 2 times 3 on the inside because those weren't marked out. So 2 times 3 is 6. Radical 2 times 3 is 6. Final answer. Please pause the video and give them a chance to do B on their own paper. Once they've gave it a shot, go ahead and hit play so that they can check their answer. Okay, on B we're going to split it into the prime factorization again. So 210 will split into 3 and 70. 3 is a prime. 70 splits into 7 and 10. 7 is a prime. 10 splits into 5 and 2. Okay, looking at this, I have 2 times 3 times 5 times 7. I do not have any doubles there. So this is as simplified as this problem is going to get. Okay, final answer. Instead of walking 200 yards from point A to point B, Arnold takes a shortcut across the field. So this is like if this was a road. This is my house and this is the school. And instead of walking on the road, I'm just going to cut through people's yards because I'm kind of rude like that. Okay, so I'm going to take this path instead. So it says, how long is the shortcut? Well, right here we can see that we have a right triangle. Okay, and whenever we have a right triangle, we can use the, I hope you said Pythagorean theorem, okay, which is a squared plus b squared equals c squared. Okay, so A would be, A and B are where that right angle symbol is touching the legs of that right triangle. So we know that A is 100, we'll square it, plus B is 100, we'll square it, equals c squared. That's what we're looking for, this distance here. Okay, so 100 squared is going to give us a 1 with 4 zeros, so 10,000 plus 10,000 equals c squared. 10,000 plus 10,000 is 20,000 equals c squared. Okay, now we know that the opposite of squaring is square rooting, and I have to get c by itself, so I have to square root. What I do to one side, I must do to the other. Those will cancel. So I'm left with c equals, and whenever I do this, I'm going to write my equal sign on the other side because we have to break it down. Okay, so 20,000 will split into 200 times 100, and this one will split into 2 times 100. So I have this prime, and I have 100 and 100. So this is the same as saying radical, we'll split it differently this time, radical 2 times radical 100 times radical 100. Well, radical 100 times radical 100 is equal to 10. So I have 10 times 10 times that radical 2, which gives me 10 times 10 is 100, and then I have radical 2 yards. Okay? Now, whenever we find this answer like this, though, this is like whenever we were first solving these type of problems, and I said, well, how far is 100 radical 2 yards? How far is that? Well, we don't know how far it is, so we have to use the approximation. So the approximation for radical 2, you may or may not remember. If you remember, great. If you don't, the way we find it is by punching it into our calculator. So we're going to take 100 times that 1.41 yards. Okay, it's still yards because that's the distance. And whenever we multiply those out, we get 141 yards. That would be the distance. So a little less than 1.5 football fields to give you some perspective. In example 2, we estimated the length of the shortcut using radical 2 is approximately 1.41. It is helpful to remember some appropriate values of frequently encountered square roots. to one or two decimal places. So once again, you do not have to remember this because you have a calculator. If you don't remember it, punch it in, round it to two decimal places. Your homework today, lesson 74, A through K, 4 through 24. If you're talking, that's going to change. If you're in the class that is in trouble, then you already get to do all of the problems. So please show me that you don't want to have to do that anymore by working quietly and individually. This is due when you walk in the room tomorrow. It will be graded. Be good. I hope you have a good rest of the day.